Okay, Ling 441, I just want to walk you through the categorical perception homework, which is going to be due on Monday the 30th. So this is going to be based on the mini categorical perception experiment we did, well, that you're supposed to do at home, that we normally do in class. So this is the experiment where you are first doing an identification task, where you identify synthetic speech stimuli as either ba, da, or ga. And then there's a discrimination task after that where you have to discriminate between two completely identical stimuli or between two stimuli which sound pretty similar but may be different. So it's a tricky task to do, as we found out. But remember that the idea for categorical perception is that you can predict the performance on the discrimination task from listeners' performance on the identification task. So I have tabulated your data for this, or I will have tabulated your data for this. It's always fun to use the future perfect tense. Again, I'm still recording this in the summer here, and you guys haven't actually done this experiment yet, but ideally you should do it at home and send me your data, and then I will tabulate that data and include it in this homework. So what I've got here is what the homework has looked like every single previous year, but the numbers are going to look a little bit different once you guys see it. So this is from last year where I give you the identification data. So there's 11 different tokens in the experiment ranging on a synthetic or an acoustic continuum. They're synthetically produced and they range on a acoustic continuum. So for token 1, you get this number of ba responses, this number of da responses, this number of ga responses, so on and so forth. And I've also split it up according to whether listeners have done this task before, or whether or not they have, if they have done the task before, they're experienced, and if they have not, they're new listeners. So this experiment doesn't seem to be done in psycholinguistics anymore, so most of you will probably be new listeners, but we're going to still hang on to the data from those in the past who did it before they did it in this class too. And we'll see if the experienced listeners do anything different from the new listeners. There's also response data here at the end of the homework handout. So this shows you for different stimuli, which are always paired up 2 steps apart from each other on the continuum. How many times did people respond same? How many times did they respond different? So these are all different stimuli underlyingly. The correct response is that they should all be different. As you can see, this is a difficult task. People don't often hear these as different, but some pairs sound more different than others. So the 4-6 pair, you get a lot more different responses than for the 1-3 pair, right? The idea is that maybe the 4 and 6 tokens are across a category boundary, and that makes it easier to hear this difference. We see the same kind of pattern lining up for the new and the experienced listeners, but that's getting sort of above and beyond ourselves because we can't just look at specific individual pairs and make predictions on the basis of that. We need to look at all the data. So for the same reason, I don't want you to just look at the pairs of different stimuli. So like in the original graphs for the categorical perception experiment from Lieberman et al. 1957, they just looked at the responses to the different pairs. I want you guys to take a look at the same pairs as well and see if you find anything kind of fun or interesting in them. So you'd expect these to all be same responses, right? Because these are the exact same token played twice, and then listeners respond either same or different. It turns out listeners do not always respond same. Sometimes they respond different, so that's kind of funny, but true. And maybe the new listeners are doing something different from the experienced listeners. We don't know yet. I just realized I need to fix this number, but you're not going to see these exact numbers in your homework anyways. I got to update them for your responses once you send them to me. So yeah, what I want you to do, that's what the data look like underlyingly. So for both the new and experienced listeners, I want you to plot separate graphs for the following 3 sets of data. So number 1, the identification responses. How often was each stimulus identified as ba, da, or ga? And you can make the graph any way you want, whether it's in Excel or by hand or whatever, but it should look something like this. So we don't have 14 different stimuli in this experiment, we just have 11. But you should, for each one, plot how many times it was identified as ba, da, or ga. And then I want you to create separate identification graphs like this for the new listeners and the experienced listeners. Yeah, it'll probably be easiest for you to do those in literally 2 separate graphs. But again, if you think of a way that makes sense to you and that works, go ahead and do it however you like, just as long as all the relevant information is in there. For the different pairs of stimuli, I also want you to plot 2 graphs together, just like down here. This is showing you the predicted curve based on the identification data and also the observed curve of actual responses in solid line form on the same graph. And the reason that Lieberman et al. Did this is because they kind of wanted to see how well these matched up. The kind of theory behind categorical perception, again, is that these two should match up basically exactly. And remember, I walked you through in the lecture how to calculate the predicted number of responses for any particular pair of stimuli. Do that, use that math and the numbers from these tables to make predictions about how often you're going to get, well, I think I asked you to plot different responses up here for these 2 graphs. So plot the observed discrimination function. That one's the easy one because it's based on the numbers in these tables right here. So just plot how many times in this particular case do the listeners hear the stimuli as same or different. I have this listed out as same or different. You really only need to pick one. And it might be easier because there's different pairs of stimuli to just plot the number of different responses. There's all sorts of little details in here I need to fix, but they will be fixed before November. Because you respond either same or different in this task. So if you respond with like 60% different, and that means there's going to be 40% same. So you don't really need to plot both same or different on here. Just pick one and go with it, and then use the same response category for this graph as well. So this is a predicted discrimination function. This function should show the percentage of different responses that would result from purely categorical perception of the stimuli as based on the identification data. So for example, given the percentage of times listeners identified stimulus 1 as ba, da, or ga, and stimulus 3 as ba, da, or ga, how many times would listeners perceive those 2 stimuli as categorically different? And to do this, just walk through the math as it's presented in the lecture and then in the video on the lecture too. So what I want you to do, this is for the different pairs of stimuli, but I want you to plot observed and predicted on the same graph, but there's 2 graphs, one for the new listeners and one for the experienced listeners, just to see if they're doing anything different. And likewise, do the same thing for the same pairs of stimuli. So for the same pairs of stimuli, plot first of all the observed data, which is down here, and then based on the identification data, you should make predictions on how often people should perceive the same stimuli as same. So plot an observed discrimination function and a predicted discrimination function on the same graph, but do that for 2 different groups of listeners, 1 the new listeners and 2 the experienced listeners. So it's going to look, well, yeah, same basic idea for both different pairs of stimuli and same pairs of stimuli, but obviously different data, and you're looking at 2 different groups in both cases. Once you're done plotting of the graphs, then I want you to answer a couple, or actually 3 questions. And you're welcome to speculate in your answers if you don't know the exact answer. And in particular, you can give me some wild and crazy thoughts about how you think speech perception might work. So number 1, do the identification functions accurately predict the discrimination function for each group? For the different pairs of stimuli, are the listeners doing better in the discrimination task than what would be predicted from the identification data, or worse? Better is in quotes here. This is not really, you can interpret it as if there's a right answer here in terms of whether they're identifying pairs of stimuli as same or different correctly. But what we care about is not whether they're getting that right, but what the listeners are actually doing. Because, we're trying to get into people's minds with this, not sort of figure out what we already know about the stimuli. So likewise, are listeners doing better or worse on the discrimination task than would be predicted for the same pairs of stimuli? Do you see any sort of different patterns for the different or same pairs of stimuli? To put this another way, when we're looking at whether or not the observed and predicted curves match up with each other, we're asking the question, do these data support the notion that human beings perceive speech categorically? So try to answer that question based on what you can see in the results, and also based on what you understand about categorical perception. Number 2, are there meaningful differences in response patterns between those listeners who had done this experiment before and those who had not? More generally, do you think it might be possible to learn how to perceive these stimuli in a non-categorical fashion, or that experience might help a listener discriminate them on a more fine-grained acoustical basis? So this is where you can start throwing in some wild and crazy thoughts. I'm happy to hear them. It's always fun to think about speech perception from a new perspective. Or you can just kind of matter-of-factly let me know precisely what you think. Either way. And thirdly, just kind of a reminder question, why should place perception be so dependent on F2 transitions? In other words, what do F2 transitions tell us about the state of the vocal tract? Yeah, so what you need to send me is a little write-up about this, along with your graphs of the data. And there's a Dropbox on D2L for that purpose. And you can send it to me by email as well. And I'm around during office hours and on email if you have questions, as usual. Hopefully that all makes sense. If it doesn't, just get in touch with me. And otherwise, I'll be looking forward to what you guys come up with. All right. Talk to you later.